In this lesson, we're going to have a quick review of some of the important things that you need to know about linear conversions and area of some basic shapes, area as well as perimeter. So first of all, let's have a look at some of the basic things that we know as linear conversions. Linear means line, a line or a straight line, as opposed to area, which is another form, and it's based, area is based on lines, as you know. You square lines, you get areas, and volume, which is cubes. Now, we're not going to worry about the volume side of things in this lesson, but we are going to have a look at area, and we're going to have a look at linear conversions. The important thing to know is that these are numbers that should be well learned. That is, 1 kilometre is 1,000 metres, 1 metre has 100 centimetres in it, and 1 centimetre 10 millimetres. And here's a little diagram that illustrates how to transfer between them. Now, let's have a look at our first example, converting 50 millimetres to centimetres. We write down our 50 millimetres, and that's what we're converting. So we say that it's equal to our 50, and we're going to divide it by 10 because we're going from millimetres to centimetres, so there's a division by 10. Simply means for every 10 millimetres we have 1 centimetre. So we're finding bundles of 10 millimetres, and in this case we have 5, so it's 5 centimetres. On the other side, we're converting kilometres back to metres, so we're going this way. And we know that there are 1,000 metres in a kilometre, so it's a multiplication. So we can say that 8.6 kilometres is going to be this. Here's our equation. If we take our 8.6 and we times it by 1,000, then we get 8,600 metres. So there's our conversion as far as linear measurements. You need to practice these because they're very, very important. Okay, let's have a look at some area conversions now. These are harder to learn, so I'm going to teach you a little bit of a method, or maybe even remind you of a method. Notice here that if we've got 1 centimetre equals 10 millimetres, that if we square every part of it, we actually get into area. So 10 squared is 100. So 100 millimetres squared is equal to 1 squared, which is 1 centimetre squared. So by squaring these two numbers, we convert to area type measurements, and 100 millimetres squared. So there's 100 square millimetres in 1 square centimetre. This one here, you just need to remember that the hectare, 1 hectare is 10,000 square metres. That is one you just have to remember, just as you learn the other ones. It's just a knowledge thing, because there's no real link. You've just got to learn that 1 hectare is 10,000 square metres. And here's a diagram that helps you work these out. Now, I'll let you look at this in your study booklets a little bit longer. So if you want to pause and have a look through this, you can. But I'm going to continue in a moment with showing you how to do these conversions quite simply, even if you don't have this diagram, as long as you remember your linear measurements. Let's have a look at how these are done. In this particular case, we've got 25 centimetres squared, and we're going to convert to millimetres squared. So we start by saying that 1 centimetre is equal to 10 millimetres. Now, when we convert these to squares, we square everything. Now, writing this out properly, we get 1 times 1, that's 1 centimetre squared, is equal to 10 times 10, that's 100 millimetres squared. So we can go from linear to square units here. So that means if we want 25 of these, then we need to multiply 1 by 25. So if I multiply this by 25, therefore I must multiply this by 25, I actually get my answer. 25 centimetres squared is equal to 25 times 100, so that's 25 with 2 noughts on it, millimetres squared. And there I have my answer. What about when we go the other way? Well, let's start with what we have with 100 centimetres and linear measurement. All right, so let's start with 100 centimetres is equal to 1 metre. That's the units linear. Remember, no area, no volume, centimetres and metres. 100 centimetres, 1 metre. Now we'll square these. So we get 100 squared centimetres squared, and we've got 1 squared. So we're squaring it to make it into area units. This gives us 10,000 centimetres squared to every 1 metre squared, because 1 squared is 1. So there's 10,000 centimetres squared in every square metre. Now, in order to get this 10,000 back to 2,000, I think you can see we've got to divide by 5, because 2,000 goes into there 5 times. So if I divide this by 5, I actually get 2,000 centimetres squared. But because I've divided this by 5, I have to divide this by 5 as well. And this takes me down, if you use your calculators, you'll find this, to 0.2 metres squared. So there's my solution, dividing both sides by 5. Now, once again, practice these and you'll get them right. Now, to finish off this unit, we're going to have a quick review of the things we've done so far, and maybe just some things you did earlier in other units. So let's have a look at some simple calculations. First of all, a circumference. Remember, we're looking at circumference. So we know that circumference is equal to 2 pi r. So we could say that circumference is equal to 2 times pi times our radius of 8.2 centimetres. And when I write this out, or if I have it in my calculator, it starts to go like this, and then I'm going to stop because there are a lot more numbers, and therefore if I round it to 1 decimal place, I've got 51.5 centimetres. So there's your first skill, circumference. We did this earlier. You should know how to do those. Don't forget, you need to learn the correct formula. Circumference 2 pi r, or remember also pi d if you're given the full diameter. All right, let's have a look at another common shape, the area of a rectangle. Now, this is very easy for those that have done it before. You just need to remember that the area is equal to length times the breadth or the width, and in go the numbers. So the length is 3.5. Well, actually, we'll go with the length being 6.8 down the bottom, because that does seem the longer one. Wouldn't matter which way you go. 3.4. They could come in any order as long as they're there. Now remember, we're centimetres squared now because it's centimetres times centimetres. It's area. And if I write this out, I get 23.12 centimetres squared. You can check this out with your calculator, but there's your method. Okay, so let's continue. We've just got a couple more to do. A few triangles. Remember, the area of a triangle is equal to half the base times the height. So we'll write down the formula each time for these. And substitute in. In this case, it's half times the base is right along there, that's 12, times the height, which is 5. And if you work quickly with me using your calculator, we get 30 metres squared. Clearly you don't need your calculator here, because you can go half times 12. Half of 12 is 6. 6 5s are 30. So look for ways to do it without your calculator, but you can double check with your calculator if you like. Now be careful here. Where's the base and where's the height? Doesn't matter which way we go. This is perpendicular. It's got to be the perpendicular height, 90-degree height. So we'll go half times, let's say 8 is the base. Notice it doesn't have to sit on the base. It's just got to be the side that has a 90-degree line going from it. And the height then would be 3 in this case. And notice it's in metres. So half of 8 is 4. 4 3s are 12. 12 metres squared. This one's in centimetres, so let's make sure we change that correctly. Now this is an interesting one. They look somewhat different, but if you look at this one, where's the base and where's the height? Well, what we're going to do here is we're going to have our base in this case as 2.5. So I'm going to write that down there, and therefore where would our height be? There's our base. It's got to be the distance. We'll extend it out here, up there, to the top part there. So our height then is 6. You've got to watch out for these ones because they do look a little difficult. So if you find some like this, try them out and make sure you get them right. Okay, so there's my base, and if I extend it and go up 90 degrees, I'll actually be right. So that's 6 centimetres. If I had have known that distance there, I could have worked out the distance down there. That would have been right if I had been given it, would have given me the same answer. But because I've got to work with what I'm given, that's got to be my base and that's got to be my height. So it comes out to be 7.5 centimetres squared. And just one more to finish off with, a very common shape as well, parallelogram. Oh no, there's some more, sorry, examples, so we'll have to just keep working for, I think, for one more lot. That's right. Okay, the area of this parallelogram. The area of a parallelogram is the base times the perpendicular height as well. So in this case, the base would be 10. We don't take that as our height, we take this perpendicular height as our height, 10 times 5, and that's 50 centimetres squared. And now this is our final example. I'll push this up the page a little bit. And it says find the area of these circles. Let's write down correct formulas. Pi r squared. Area, pi r squared. In this case, we've got the radius as 5. So the area would be pi times 5 squared. And if I write the answer down for this, and you can try this yourself, you're going to get 5 5s, that's 25 times pi. That's what that means. And that would be approximately equal to 78.5, what are the units? Centimetres squared. Now in this particular case, we haven't been given the radius. We have to take the diameter and halve it. So our radius, therefore, must be equal to 6 centimetres. So now we're ready to go. Pi times radius, 6 squared. That gives us 36 times pi. And putting this into our calculator, 36 times pi is approximately equal to 113.1 metres. Notice, oh no, I'm sorry, centimetres. Centimetres. Yeah, that's correct. Centimetres squared. I might just write that out again a little more neatly because it's all squashed up there. So let's get rid of this and we'll write that out one more time nice and neatly. So it's approximately equal to 113.1 and the units are centimetres squared. And notice this was to 1 decimal place. So both of these were brought to 1 decimal place.